Hello and welcome. This is an explanation for the titration lab activity. As per always, you have your rubric up here and the notes for students that will explain some of the mechanisms of it. Titrations are a very common lab technique used in many industries, quality control, manufacturing, government testing, and many more. The attached lab is an introduction where high school students made a pair of chemicals, hydrochloric acid and sodium hydroxide, both to a set concentration of 0.25 molar, which is weaker than apple juice and hand soap respectively, but it still gives good data. They then tested those chemicals against teacher-made known chemicals, 0.30 molar hydrochloric acid and 0.20 molar sodium hydroxide, respectively. And they recorded data that they got to check or verify that they had made the proper concentrations. You will look over the students' work to check that it was done properly. You will use their data to calculate the molarities acquired for each trial. You will write a conclusion, supplying results, judging their errors, and suggesting improvements. It gives you a purpose and it gives you safety just so that you can see the same things that they did. You need to then finish the pre-lab. This is one of the 4 graded areas that you have to do. It's fairly easy. You double click on the red lines, you type them out, you go from there. There are these show work sections, just like we've done in other labs, where you have to do that. You have to show work. Whether you type it out or you write it out, take a picture of it and upload it, either or, I need to see that work. Uh, After you get done all of these questions, you will be done the pre-lab. Now, you will want to work on the pre-lab together as a team if possible, either using Zoom or Teams or some other way to work together. But you definitely want to try to tackle this one together. But if you assign a little here, a little there, just make sure you read over everybody's answers and make certain that they're done. Then we have the procedures. These procedures are what the students did, not what you are doing. They're there just so that you have an idea of what they did, what their directions were, and these can help you determine a bunch of other stuff. You can then see a pair of linked videos, a video of verifying an acid and a video of verifying a base, which I'm about to make. Then you get to the next graded section, which is verifying the base. So this was the molarity set by the teacher. This was the volume the student had recorded. The student had, this is the volume the student recorded after the experiment. This is the volume of base the student started with. And then this is the molarity that you need to calculate. You need to calculate the first trial, then the second trial, then the third trial, then calculate the average of those trials. And then you're going to use this percent error where the measured value is going to be the average that you had calculated earlier, and the accepted values are going to be that 0.25 molar that they were shooting for. That should give you a percent error of how good they or how they did their accuracy. So the quality of what they did. You're then going to repeat that process for the acid. Notice again, they were given a base. They measured out this much of the base through their experiment when they had started with this much of the acid that they were verifying, and you need to determine the molarities, the first trial, the second trial, and the third trial, then calculate the average, then do this do this percent error again. So then you have the fourth and final part of this. So again, it was pre-lab, verifying the base, verifying the acid, and now we're at the conclusion. You need to figure out the results of their lab based on the data presented. So look at their data, look at all the math that was done, and then write a paragraph about did they do a good job, did they do a bad job, why not, provide data as evidence. I mean, did they get to that 0.25 molar? Were they close? Were they far away? Why? You also may want to look at the next section, which has their errors. They have 6 errors labeled A, B, C, D, E, F, and the errors are listed here as to what they did. What you need to do during this section, what your job is you need to just say, was this a major error or a minor error? That's it. That's all you have to do. Was this an error that had a significant effect on the data, or did it barely have any effect and didn't do anything? And last but not least, how would you improve this lab to do better? So you can look at the errors, you can look at the procedures, you can look at all sorts of stuff like that, but you want to make sure that what you do is the best of your combined abilities, and that you check each other's work. You communicate with each other either using comments on your document or by meeting in Zoom or a Teams meeting. Good luck. Take care. Farewell.